In this lecture, we will see how to find partial derivatives of a function. Needless to say that the technique for finding ordinary differentials are absolutely applicable. Only the notations and the indexings are slightly different that we'll see now. Let us take a two-dimensional function u of x and y. By two-dimensional, we mean that u is a function of two independent variable x and y are both spatial dimension. Of course, one of them can be time, and the basic discussion that we will have now that will not change if one of them is time. But for simplicity of discussion, we take that both x and y are spatial dimension. The interval we are taking here for x goes to a to b and y goes to c to d. So overall, this x and y creates a rectangle that goes from x a to b and y c to d. And within this rectangle, we have several discrete points that are shown here as these blue dots. These are our grid points. Once again, for simplicity, we assume uniform grid. X equal to a is given by I equal to 1, and then we have m grid points in x, so it goes up to x equal to b as I equal to m. Similarly, y equal to c comes as j equal to 1, and it all the way goes up to j equal to p at y equal to d. Since we have taken uniform grid, xi plus 1 minus xi is always delta x, and j plus 1 minus yj is always delta y. So index I indicates x and index j indicates y. That means I equal to 1 means we are talking about x equal to a. I equal to 2 means x equal to a plus delta x. I equal to 3 means x equal to a plus twice delta x, etc. So in general, any point is given by an x coordinate which is a plus I minus 1 delta x and y coordinate which is c plus j minus 1 delta y. That means we denote this u a plus I minus 1 delta x plus c plus j minus 1 delta y equal to uij. So the physical xy location is now in discretized domain is the ij location. In this course, we will be interested about the partial derivatives del u del x, del u del y, del 2u del x2, del 2u del y2, and sometimes we will have cross derivatives such as del 2u del x del y. There are also other notations we may use, that is del u del x is denoted by u subscript x, del u del y is u subscript y, del 2u del x2 is u subscript xx, etc. As it were in the ordinary differentials, the partial derivative del u del x, for instance, at grid point ij that is shown here will be given by ui plus 1j minus uij divided by delta x, and this is first order accurate. We know how we get this expression. If you are not convinced, you can expand in multivariable Taylor series and you will find the same expression. Here you can see that this yellow portion, which is what we call is our stencil, this stencil will be useful for finding derivatives. We know that in which region we can get the points that are required for the derivatives. The midpoint is the ij. The left side is I minus 1 j, that is simply jumping in x coordinate 1 delta x left side, and then in right side this another green point is I plus 1 j, that is once again jumping in x direction delta x. Similarly, these red points are j plus 1 and j minus 1, which are jumping up and down in y direction in delta y up or delta y down. So again, in forward difference, we can take simply by taking I plus 1 j and ij, this difference divided by the distance between them, that is delta x. The backward difference is ij minus ui minus 1 j, once again divided by delta x, since this is uniform grid, and we know this also has the order of accuracy of delta x. In central difference, we have ui plus 1 j minus ui minus 1 j by twice delta x, and this has an order of accuracy of delta x squared. Similarly, we can evaluate del u del y at ij. This time we have to go only up and down, that is, we have to take care of these red points. So I have the forward difference now is ui j plus 1. J plus 1 means going 1 point up, that is going delta y up. So ui j plus 1 minus ui j divided by delta y. And in backward difference, we have uij minus uij minus 1 divided by delta y. The central difference is uij plus 1 minus uij minus 1 divided by twice delta y. You can carry out similar operations for double derivatives. In del 2 u del x2, once again we have to move toward these green points, and we have ui plus 1 j minus twice uij plus ui minus 1 j divided by delta x squared, which has an order of accuracy of delta x squared, and del 2 u del y2. Here we have to go uij plus 1 minus 2 uij plus uij minus 1 divided by delta y square. This YOLO structure that we call a stencil, this is an important term in CFD, and we will use this term over and over again to indicate the points that we are using for discretization. You can now check that the following expression for the cross derivative del 2u del x del y is indeed a right expression, and try to figure out the order of accuracy of this expression. Your order of accuracy will include both delta x and delta y, just to give you a hint. And if you can carry out this exercise properly, then you are all set to take on partial differential equations. So this is all for this lecture, and this is all for this week. In next week, we'll start talking about partial derivatives. Thank you.